The noise generated when a bus starts off at a bus stop is perceived as disturbing by many of the residents and passerbys. The only binding European directive, ECE R51, however, does not consider this situation. For this reason, ZF conducted comprehensive noise measurements at a typical bus stop. The question was, what is the transmission's influence on the noise level dominated by engine noise? The transmission's noise itself only plays a minor role here. The measurements were monitored by DECRA, the independent expert organization. Two city buses, technically identical but for the transmission type, were compared: ZF EcoLife and the current competitor's product by Voigt. In the first part of the measurement process, the buses stopped at the bus stops and accelerated under full load. In the second part, they passed the bus stop with 50 km per hour. 7 microphones were placed at the sidewalk, starting 20 meters before the stop, ending 20 meters after the stop. Here are the results: images and sound taken at the bus stop exit and during drive-by, measured at different microphone positions, respectively the first vehicle with EcoLife and then the bus with the competitor's transmission. First of all, the bus stop exit. You can hear the original recordings made with the microphone positioned 5 meters before the stop. The comparison shows, in particular at the stop station's critical section, the EcoLife significantly reduced the noise levels over a wide range. A maximum reduction of 5.0 decibels was measured when the bus was approximately 5 meters away from the bus stop. Now, the comparison of recordings made at some distance from the bus stop, at the microphone positions 20 meters away from the stop station. Again, EcoLife's sound level lies significantly under the results of the competitor's transmission for a long time. At this location, the highest difference in total was measured, namely 6.4 decibels, when the bus was approximately 5 meters away from the bus stop. That means, even 2 bus lengths away from the vehicle, said difference is clearly audible. Now, going over to internal noise. You will hear the recordings made with the microphone in the last row of seats, which is located in the immediate vicinity of the engine compartment. Therefore, this location is considered loudest in the bus. You can hear it. Also inside, the bus equipped with the EcoLife is quieter. The noise level is round about 5.1 decibels lower. The reason for these differences resides in the speed curve. Here you can see the values measured as graphics. In order to illustrate the interrelation between engine speeds and noise, we included the internal noise. Figures speak for themselves. With EcoLife, the bus drove with speeds of up to 690 revolutions less than with the competitor's transmission. While the Voigt transmission keeps the engine at high speeds for a long time, EcoLife shifts quickly to the following gears. Thus, EcoLife ensures that the engine is not only running in the most economical range, but also with the quietest operating conditions. And now the results with the drive-by at constant 50 km per hour. First, the external noise. The sound example was taken with the microphone 20 meters away from the stop station. Also at uniform speed it still applies. With the EcoLife on board, the noise level drops. The maximum difference was measured at the end of the test track with 3.4 decibels. Even clearer, the indoor difference. Here, recordings were made once again in the last row of seats. The EcoLife enables an audible improvement of the noise level amounting to approximately 4.5 decibels. The reason for that resides, as was the case at the bus stop exit, in the lowering of engine speeds. Here you can see the comparison of developments by means of graphics. For the entire track, thanks to the EcoLife, speeds are approximately 430 revolutions per minute lower than is the case with the competitor's product. The result, transmission selection, has a major impact on bus noise development. Here all results at a glance. Thanks to the EcoLife on board, the bus was consistently quieter than the bus featuring the competitor's transmission. The advantages generated by the ZF product are not only measurable but also audible. This aspect applies to the case of the bus stop exit as well as for the drive-by at constant speed. The cause: lower engine speeds. These in turn are due to the tried and tested concept of ZF automatic transmissions. Very brief starting phase with torque converter followed suit by 6 finely tuned mechanical ratios. The competitor's transmission has only 3 mechanical ratios and a longer startup phase. These matter-of-fact basic principle advantages do not only lead to quieter buses. Moreover, the approach enables the engine to operate in the most economical range.